Good day, everyone. Welcome to ITS 300 Web Development 1. Today, we are going to have a pre-recorded class in continuation to our web or introduction to web development discussions. There will be a learning assessment after this class. That will be through Google Form. The link will be given to you by the end of this class. And also, I will be giving you an assignment, so be sure to watch the entire video, listen, and understand the lesson attentively. My name is Julius Publico, your instructor, and today we are going to continue to the second part of our discussion about the World Wide Web. Let's get started. Now, if you have any questions or clarification about the lessons that we're about to discuss today, share it with the class, comment your questions in our Facebook group, or share it through our respective Facebook chat groups. Yeah. Previously, we discussed about the World Wide Web, particularly the Internet and the World Wide Web. We've also discussed the classification of websites and we've discussed how the web works. Now, if you haven't watched that video yet, or if you wish to review, copy the link on your screen, or you can click on this image once I've already uploaded the copy of this instructional material online. Now, today we are going to have the second part of our discussion about the World Wide Web. We will learn how the web works in further details. We will take a closer look at these three systems involved on how the web works, particularly the client, web servers, basically, the domain name system server or the DNS server, and the web server. Now, previously, we learned the overview on how the web works. So every time you click a link or type a web address on your web browser, the client or the browser sends a web content request to the web server. As the request is made, the browser uses a uniform resource locator or URL to locate the requested web content. Now, the URL is passed onto the domain name system server or the DNS server to get the IP address. Now, the DNS server locates the assigned IP address for the URL, and once the IP address is acquired, the browser uses it to locate the host server. Then the server processes the request and sends back the requested contents to the client or to the browser in HTML form. Now, for example, if we are going to look for the NORSU website, so we enter the URL on our browser. The browser sends the URL to the DNS server to get the IP address, which in this case, that will be 103.68.157.2. Now, this IP address will be used to locate the web server that hosts the NORSU website. Now, the web server will process the request by collecting the web contents, translating all of the scripts to HTML form, and sends it back to the browser. Okay? The reason why web server have to process the content first, because web browsers have limited rendering capability. It can only render HTML, CSS, JavaScript, and other client-side scripts. So the browser will translate the HTML codes to actual graphics, text, or any elements that we will see on our computer or on our smartphone's screen. Now, while this example illustrates the overview on how the web works, there are still a lot more processes involved in the client-server request cycle. So in this lesson, we are going to take a closer look on how these systems work together in order to process a simple web request, meaning we are going to take a closer look at how these or how the browsers work, how the DNS work, and how the web server works. So let's start with the web browser. Now, in our previous discussion, we knew that clients are the devices and software that request and render web contents. This includes web browsers, online games, music and video streaming applications, online shopping applications, and many more. Now, again, one of the perhaps biggest example of a web client is a web server. And that is what we're going to discuss, or we're going to take a closer look for today's discussion. So a web browser is an is a software application for accessing web content on the World Wide Web. According to Wikipedia.org, Google Chrome is the most used web browser with a total of 64% global market share on all devices. Okay, so that is followed by Apple's Safari, Mozilla Firefox, and Microsoft Edge. So again, one of the most popular example of a web client is a web server. Most of us, if not everybody, have used web browsers before. Maybe you've used it even before we study information technology. It is indeed one of the application software that we use on our phones or computers. But how exactly browsers work? Let's find out. So this is an example of a web browser, particularly Google Chrome, the world's most widely used web browser. I know you recognize this. Google Chrome is an example of a web browser. It has URL address bar here, the controls, extensions, and bookmarks, things that we usually see on just about every web browsers we've used before. Browsers use Hypertext Transfer Protocol or HTTP in communicating with the web servers in requesting web contents. Once the browser receives the web content from the web server, it uses its rendering engine to render the web content like the HTML files, JavaScript, images, videos, and any other supported files on the screen. So every time that we look for a website or click a link or maybe like a Facebook friend status update, or maybe upload our selfie photos, and just about everything that we do on the World Wide Web, the browser uses HTTP or Hypertext Transfer Protocol to process these requests. Okay. Now, once the browser receives the requested content, again it uses its rendering engine to translate those codes into something that we will see. Browsers are usually made up of different components: the browser user interface, internal engine, rendering engine, networking components, data storage, and JavaScript interpreter. Okay, so basically these are the parts of the browser that make it all work. The reason why we can see contents on our screen while we are surfing the internet. Okay, so let's discuss about the browser user interface. The browser user interface is the overall appearance of the web browser. It contains the tools, navigations, and controls on how the web browser is used. This includes the address bar, navigation buttons, menu bar, bookmark tabs, and many more. Okay, going back, let's check the Google Chrome again. So just about every other web browsers that we've encountered, it's got the address bar where we put the URL of the website that we want to visit. We have here the extensions or plugins, basically, the overall screen, and we also have here the controls. If we go back to the previous page, if you want to reload a page or go to the home page. We also have here the bookmarks. If you wanted to save a specific link for easier access the next time in the future, then we just have to save the link as a bookmark. Then we can have the bookmark in here. So all you need to do once you wanted to visit that website again, you just have to click the bookmark, and then it will automatically reload the website. Now, the browser UI allows us to set preferences on how we are going to use or how we are going to browse the World Wide Web. It allows us to enter the URL here, go back to the previous web page, go to the browser's homepage, reload the page for newer content, save and view bookmarks, and browser plugins or extensions, minimize or close the web browser, and many more. So that is the browser UI. Next component of a web browser is the internal engine. The internal engine processes any commands made in the browser user interface. For example, the user click the back button of the browser. The internal engine will then process the request by checking the browsing history, get the URL of the previous page so that it can be reloaded. So, internal engine is like the sequences of commands that make everything work inside a browser. Whatever you will do with the browser UI or browser user interface, the internal engine will process it. Okay? The next component of a web browser is the rendering engine. Rendering engine is responsible for translating HTML and CSS and rendering the content on the screen. So remember how web browsers or web servers rather are supposed to translate the web contents into HTML form before it will be sent back to the browser. This component is responsible for translating the HTML and other client-side scripts into actual visual elements. It is basically responsible for translating those codes into something that we see on the screen. The colors, objects, photos, videos, buttons, banners, and many more. Okay, depending on which web browser you're using, there are different rendering engines that makes the translation possible. We have Trident. This is a rendering engine used by Microsoft Internet Explorer and Windows mobile browsers. We also have Gecko. It is used by Mozilla Firefox, Firefox OS browsers. And we also have Opera. It is of course used by the Opera Mini, Opera Mobile, and other older Opera browser versions. And then we have WebKit, which is the rendering engine used by Apple Safari and old Android devices. And then lastly, perhaps one of the most used rendering engine is the Blink, used by Google Chrome, newer Opera, and the Android browser versions. Okay, so basically these are the rendering engine. So now you may be wondering, if there are many rendering engines out there, are there any possibility that websites may behave differently on one website to another? So whenever, yeah, is there any difference on how they behave when it comes to rendering web contents? Right now, the answer is no. However, decades ago, there was this called browser war. Now, in 1990s, during the rise of popularity of the World Wide Web, the web browser companies used to compete with each other by offering features and functionalities that other web browsers doesn't have. As a result, web developers were constantly having hard time because they will have to develop websites for different web browsers. So imagine being a web developer at that time where you have to develop and design the same website but for different web browsers just to try to make sure that viewers will have the same experience regardless of the web browser that they are using. Would it be hard? It would be hard, right? So thankfully, an international organization called the World Wide Web Consortium, or W3C, okay, was founded. The W3C, or the World Wide Web Consortium, is the main international standards organization for the World Wide Web. They introduced us the worldwide or the web standards, which are a set of standardized best practices and protocols for building websites. Of course, these help ending the browser war. So current and future web developers should be thankful with the W3C. Because of them, we can assure that whenever we are going to build a website, we don't have to build it multiple times specific for a certain web browser. So we can assure that the website that will be working will work just the same regardless, or it will work according to how it is supposed to, depend regardless of the web browser that the viewers are going to use. Okay, the next component of a browser is what we call the networking components. The networking components are responsible for sending and receiving HTTP requests. So the networking components are responsible for sending and receiving HTTP requests. That means everything that we do on the World Wide Web translate into HTTP requests. Whether if you're just going to like your Facebook friend status update, if you're going to send someone a message, a private message, or let's say if you post a comment to your friend's selfie, all right, or the food selfie that maybe your best friend posted online, which you are not invited. So that translates to an HTTP request. So for example, if we are going to look up for a website, the URL is sent to the DNS and web server through HTTP. Okay, so everything that we are doing online translates to HTTP requests. So HTTP is basically a protocol that is used for sending and receiving web contents. It is like a series of instructions that sets an agreement between the client and server that they are going to exchange web contents. Okay, the next browser component is the data storage. The data storage is responsible for the session management and storing web cache and cookies. The data storage is responsible for many things. Again, first is the session management. Session is a temporary and interactive information interchange between the browser and server. Now, this includes logins. So whenever you are logged on a certain website, you will remain logged in even if you close the browser tab or the browser itself, unless if you are going to choose to log it out. Data storage is also responsible for saving web cache and cookies. Cache is if you have noticed on your Facebook app on your phone. Now, even if you are offline, you can still view the Facebook posts and other contents since the last time that you were online. Okay? That is because of cache. Of course, it will consume device memory, thus, excuse me, it can be a reason why your phone is lagging. So when your phone is running out of storage space, you can clear up the app settings or you can clear up the cache by going to the app settings and tap clear cache. Cookies are small pieces of data, usually text files or the server sends or usually the text files that the server sends to the browser. Now, for those who have no idea what cookies are, now maybe you've experienced this. Have you noticed that some websites you visit, there's always some kind of agreement, usually at the bottom of the screen that says, this site uses cookies. So it will either ask you to either accept the cookies or agree and something like that. Okay? So how exactly or what exactly these cookies? So basically here is how cookies work. Now, imagine you are filling out a form on a website. So let's say you are applying for an NBI clearance. You enter your first name, okay, and then your last name, all right, so on, and then so on and so forth. Then you continue to the process, click save, and you're done. Now, if you're going to fill out the form again the next time on the same browser and the same computer, so whenever you click the first name, right, or whenever you click on the input box where you had previous entry, let's say first name, the previous entry will display as a suggestion. Okay? Again, if you've entered first name, if you've entered, let's say, Steve on the first name previously, and then you saved to reload the page, you enter something or you type, if you wanted to type onto the first name again, the previous entry will be displayed as drop down as a suggestion. Okay? So you can either type a new name or you can enter new entry, or you just have to click and then it will automatically be added. Same thing with the last name. You can either just type a new one or just click it. All right. So basically, that is how the cookies work. Now, the cookies are only saved on whenever you accept the cookies. That website will just going to allow your computer to save your previous text files. So the text files could include, again, this input form, maybe password, and so on and so forth. So that is what cookies are. The next and the last component of a browser is what we call the JavaScript interpreter. So from the term suggests, it renders JavaScript. Now, if you don't know what JavaScript is, it is a programming language specifically for making dynamic web contents. So while HTML, CSS, and other client-side scripts will be rendered using the rendering engine, web browsers have separate interpreter for JavaScript. Okay, so that is all about the web browser. So next is we're going to discuss about the second system in the World Wide Web, which is the DNS server. Again, the DNS server, or the domain name system server, is a hierarchical naming system for network devices. It serves as the phone book of the internet. But instead of phone numbers, it uses IP, or Internet Protocol addresses. When a web server hosts a website, a unique IP address is assigned to be used in locating its content. The IP address will be registered to the DNS server. Since memorizing these IP addresses may take a lot of work for us humans, the DNS comes to help. So again, every time that you're going to host a website, that website will be assigned with a specific IP address. Now, how? Okay, how exactly the website will be registered with an IP address? You don't have to worry about that because most of the time, whenever you host a website, of course, you're going to pay for a domain or a web hosting services. Your web hosting company is the one who are going to register your website onto the DNS to get the IP address. Now, again, the DNS server is the second point of the web request journey. We already knew that it helps the browser in looking for the IP address of the server where the web content is located. So right now let us take a closer look on how exactly the DNS server works behind the scene. So again, going back, we already knew how the DNS works. We already have an idea how the DNS works as an overview. So the if we enter the URL, the URL will be sent to the DNS server to get the IP address, and then the process continue. However, or whenever a request for a web content is made, the client sends the URL to the local ISP DNS server. Okay, so that is the very first thing that the DNS, or that is the first step on how the IP address will be acquired. First is the web client or the browser sends the request or sends the URL to the local ISP DNS server. So what exactly is this local ISP DNS server? So from term suggests, it is a local DNS server typically situated with our ISP or Internet Service Provider. Okay, so the browser will check the, the local ISP DNS server for the web server's IP address. Now, if the IP address is acquired, then the process continues. Again, the IP will be used to locate the web server. The web server processes the request, translate the contents to HTML, and sends it back to the browser. Easy. Okay, so again, the client will going to check first to the local ISP DNS server to check if the IP address is there. However, whenever the IP address cannot be found in the local DNS server, okay, so there is this group of servers called root name server. So this guy knows everything since it covers all the registered and hosted websites around the globe. The URL will be sent there instead to find the domain name of the website. So when we say domain name, for example, facebook.com, Facebook is the domain name. And then the root name server communicates with the .com server. Okay, the .com server stores the IP address. So together, they belong to what we call top level domain. So since IP addresses, so if the IP address will be acquired, then the process continues. Okay, now if the IP address is not present in both the local ISP and the top level domains, that is where you will get an error message or a DNS error message on your browser. Okay, so again, if whenever you are going to visit a website, the client will check first on your local ISP DNS server to check whether the ISP or the IP address is there. However, if the IP address is not present, then the URL will go to the root name server to check if the IP address or if the website, the URL, the domain name of the URL is located there. Okay, and then the root name server will communicate with the .com server to check the IP address. However, if the IP address cannot be found in both local ISP and the top level domain, which is the root name server and the .com server, then you'll get a DNS error message. Okay, so DNS caching helps the retrieval faster by saving the IP address to the local ISP DNS server. It means if you visit the same website within 24 hours, there will be no need to retrieve the IP address to the top level domains again, thus making the process faster. Okay, last we are going to discuss about how exactly the web servers work. Again, web servers are just any computer installed with specialized application and components intended for serving web requests. Web hosting is the term referring to posting a website or a web page onto the web browser. So even the computer that you may be watching from right now can be a web server. It just needs to installed with specialized application and components for it to become one. Okay? Now, websites are stored in the web server as a series of files and folders, just like saving a file in a computer's local disk, right? So from the moment that a request is made, the web server pulls out and translate the contents included in the request. All right. So that may include the actual HTML and other structuring scripts, style sheets, JavaScripts, images, and many more. Now, for dynamic websites, the server processes and translates the application data and database script into client-side languages like HTML before it will be sent back to the browser. Again, this is for dynamic websites or those websites that has um, server-side scripting languages like PHP. So the PHP and let's say the database, which is the MySQL, will be processed first using the web application and the database server before it will be translated to or so that it will be translated to HTML before it will be sent back to the browser. Now, for example, PHP scripts and database records needs to be processed first and translates to HTML. Now, once the content are translated, it will now be ready to be delivered back to the web browser. But how does web servers do all of these? So, going back to the web server definition, web servers are any computer installed with specialized software applications and components necessary to serve web requests. This is through the use of what we call a web stack. Okay. Web servers consist of web stacks. Web stacks are groups of software that work together to build and process websites. Web stacks are what make any computer a web server. Now, web stack usually consists of an operating system, web server, database server, and programming language. So operating system supports the web server function. Of course, any computer will not work without an operating system. So that's the first thing that a computer needs to have for it to become a web server. Operating system. Next, web server. So the actual web server processes web requests. It is a software application that do all the processes on the web requests. Next is a database server. Database server stores data from the website and process data requests. And then lastly, a programming language. It translates programming scripts from the website. So as a web developer, it is very important for us to know the web stack that a web server offers before you host a website. Now, an example of a web stack, and perhaps the most commonly used web stack online, is LAMP. LAMP stands for Linux, Apache, MySQL, and PHP. So Linux, of course, that is the operating system. Apache, that is the web server. MySQL is the database server. And then PHP is the programming language. Again, web stack must always consist with operating system, web server, database server, and programming languages or programming language. And LAMP, this is what we have for LAMP. LAMP is one of the most commonly used web stack online. And here are another notable web stacks. Maybe some of you have heard WAMP and XAMPP before. So these two are pretty much the web stack that NORSU Bais has been using for the past years. So another example is the MAMP, which is of course stands for Mac OS, Apache, MySQL, and PHP. WAMP, again, the one of the web stacks that we've been using in NORSU Bais for quite a while now. WAMP stands for Windows, Apache, MySQL, and PHP. And then lastly, we have XAMPP, cross-platform. That's X stands for cross-platform, meaning it supports multiple operating systems. A stands for Apache, P stands for PHP, and Perl. So soon, maybe on in our web development too, we will be able to start with um, the dynamic web pages. So if we will learn about, if we were going to study PHP, we are going to use this web stack so that we can learn PHP in our school. Okay, so I think that's it. Again, if you have any clarification, if there are some parts of the video or the lesson that you didn't really get, of course, please let it be known. Comment your question on our Facebook group or send it through our Facebook chat groups. Okay, so I hope you guys understand something, and now we already have a broad idea on how exactly the World Wide Web works. So imagine we've been using world or internet or the World Wide Web for quite a while. It is one of our favorite things to do over the internet. And maybe after this class you will be able to understand how these things work, how the World Wide Web works. And imagine all of these processes will be made in just a, maybe in a matter of seconds. The moment that you enter the URL, let's say facebook.com, once you click enter or click enter, the content is already in your screen in just a few seconds. So imagine all of these processes, very complicated processes, is done amazingly fast. So at least right now, I hope you already have an idea on how the web works. And then this is very important for us to learn when we are developing a website. At least we already have a foundation on why things work and why they work as they were. Okay, so that's it for today, guys. So again, as promised, there will be an assessment for you. So please fill up the form today for your assessment. Copy the link on your screen and also be sending the link on our Facebook chat groups as well. So the deadline would be November 20, Friday, Friday, November 20, 2020 at 11:59 p.m. And assignment, please check the assignment on our Google Classroom. I'll be uploading an assignment soon. Same, the deadline would be November 20, 2020 at 11:59 p.m. Right, so that's it for today, guys. Thank you so much for making this part of the video. Keep safe, and God bless us all.